Today we're going to talk about the storage and handling of moisture-sensitive devices. Any plastic IC package will absorb moisture from the air. When the package is exposed to the sudden high temperatures of solder reflow, this moisture can expand rapidly and damage the component. Sometimes the damage is visible, such as cracks in the package. Other times it's internal and it's not visible but can lead to early product failure. The smaller, thinner packages with less space around the die are more prone to this type of damage. Moisture-sensitive devices can be ICs, LEDs, and even connectors. They require special handling and record keeping. These parts arrive at our facility in special moisture barrier bags. The bags are labeled with a moisture sensitivity level and other information. We inspect the bags for tears and store them until we need the parts for assembly. We don't open the bag until we're ready to use the parts. Each bag should contain a humidity indicator card, which we use to confirm that the parts have not been exposed to moisture during storage. Then we have to complete all assembly and solder reflow operations within the floor life window of the part. The floor life is the amount of time a part can remain outside the bag before it has a chance to absorb enough moisture to make it susceptible to damage during solder reflow. This can be as little as 24 hours or as long as a year, depending on the part's moisture sensitivity level, as well as the temperature and humidity in the factory. If a second reflow operation is needed, it also has to be done within the floor life window. In a high-mix manufacturing environment, we often use a batch of parts in multiple production runs, which can span over months or years. So between runs, we return the parts to a moisture barrier bag, add fresh desiccant, and a humidity indicator card. Then we heat seal the bags with a light vacuum. Floor life is cumulative, so we have to keep careful records with every production run to ensure that we don't exceed the total floor life. The bag is marked with a seal date and returned to storage. If the floor life is exceeded, the parts have to be baked at a constant temperature and 5% relative humidity. The bake oven gently and slowly evaporates or bakes off any moisture inside the package. The temperature and duration of baking depend on the part's moisture sensitivity level, the package type and thickness, and by how much it has exceeded its floor life. If you supply moisture-sensitive devices to your contract manufacturer, be sure to follow proper handling procedures and provide accurate documentation. We have received parts which were over-vacuumed during sealing, compressing the reel and causing some of the parts to flip and twist inside the tape. We've received moisture-sensitive devices on reels that couldn't handle the specified bake temperature. And we have received moisture-sensitive parts in loose bags without desiccant, which means we have to bake them before we can use them. Baking causes oxidation that reduces component solderability and impacts our material flow and production schedules. So we reduce the need for baking and the risk of part damage by storing parts properly, keeping careful records of cumulative floor time, and scheduling production accordingly. You can learn more about handling moisture-sensitive devices in the article in the link.